translate an IP address into a host name, and hosts is one of the simplest. You can create a file called hosts and enter a line in the file for every system. Here is an example: 198.34.56.25 myserver.com. My server's information 198.34.57.03 yourserver.com. Now comes the nasty part. You must store this ASCII file on every single workstation on your network. When you make a change, you must change the contents of the host's file on every single workstation on your network. This is a simple but painful process inside a network. But what happens if you want to go outside of this network to other networks or the internet? File size would be simply enormous. Fortunately, there are better solutions, as you will see in the next two sections. Using DNS, the abbreviation DNS stands for Domain Name Service. You use DNS to translate host names and domain names to IP addresses and vice versa by means of a standardized lookup table that the network administrator defines and configures. The system works just like a giant telephone directory. Suppose you are using your browser to surf the web and you enter the URL http://www.microsoft.com to go to the Microsoft homepage. Your web browser then asks the TCP protocol to ask the DNS server for the IP address www.microsoft.com. When your web browser receives this address, it connects to the Microsoft web server and downloads the home page. DNS is an essential part of any TCP IP network because it simplifies the task of remembering addresses. All you have to do is simply remember the host name and domain name. DNS tables are composed of records. Each record is composed of a host name, a record type, and an address. There are several record types including the address record, the mail exchange record, and the canonical name record. The address record, commonly known as the A record, maps hostname to an IP address. The example below shows the address record for the host called mail in the company.com domain. Mail.company.com INA204.176.47.19. The mail exchange MX record points to the mail exchanger for a particular host. DNS is structured so that you can actually specify several mail exchangers for one host. This feature provides a higher probability that email will actually arrive at its intended destination. The mail exchangers are listed in order in the record with a priority code that indicates the order in which the mail exchangers should be accessed by other mail delivery systems. If the first priority doesn't respond in a given amount of time, the mail delivery system tries the second one, and so on. Here are some simple mail exchange records: hostname.com IN mx10mail.company.com, hostname.company.com IN mx20mail2.company.com, hostname.company.com IN mx30mail3.company.com, mail.company.com. In this example is if the first mail exchanger mail.company does not respond, the second one mail2.company.com is tried and so on. The CNAME record or canonical record name is also commonly known as the alias record and allows hosts to have more than one name. For example, your web browser has the host name www and you want that machine to also have the name FTP so that users can use FTP to easily manage web pages. You can accomplish this with the CNAME record, assuming that you already have an address record established for the hostname www.a CNAME record that adds FTP as a host name would look something like this: www.company.com INA 204.176.47.2 ftpcompany.com CNAME www.company.com. When you put all these record types together in a file, it's called a DNS table, and it might look something like this: mail.company.com INA 204.176.47.9 mail2.company.com INA 204.176.47.21 mail3.company.com INA 204.176.47.89 yourhost.com.inxmx10 mail.company.com yourhost.company.com.inxmx20 mail2.company.com yourhost.company.com inmx30 mail3.company.com www.company.com INA 204.176.47.2 ftpcompany.com INCNAME www.company.com. Using WINS. WINS or Windows Internet Naming Service is an essential part of the Microsoft networking technology. But before we go into discussion of WINS, we must define a few terms, including these two protocols: NetBIOS and NetBEUI. NetBIOS, pronounced NetBIOS, is an acronym formed from Network Basic Input Output System, a session layer network protocol originally developed by IBM and Cytec to manage data exchange and network access. NetBIOS provides an API application programming interface with a consistent set of commands for requesting lower level network services to transmit information from node to node, thus separating the applications from the underlying network operating system. Many vendors provide either their own version of NetBIOS or an emulation of its communication services in their products. NetBEUI, pronounced NetBEUI, is an acronym formed from the NetBIOS Extended User Interface, an implementation and extension of IBM's NetBIOS Transport Protocol from Microsoft. NetBEUI communicates with the network through Microsoft's NDIS Network Driver Interface specification. Today, NetBEUI is shipped with all versions of Microsoft's operating systems and is generally considered to have a lot of overhead. NetBEUI also has no networking layer and therefore no routing capability, which means that it is suitable only for small networks. You cannot build internetworks with NetBEUI, and so it is often replaced with TCP/IP. Microsoft has added extensions to NetBEUI in Windows NT to remove the limitations of 254 sessions per node. This extended version of NetBEUI is called the Net Bias Frame (NBF). WINS is used in conjunction with TCP, IP, and maps net bias names to IP addresses. For example, you have a print server on your LAN that you want to come to know as print server 1. In the past, to print to that server, you need only to remember its name and to select the name from a list. However, TCP/IP is a completely different protocol and doesn't understand net bias names, therefore has no way of knowing the location of those servers or their addresses. That's where WINS comes in. Each time you access a network resource on a Windows NT network using TCP/IP, your system needs to know the host name or IP address. If WINS is installed, you can continue using the net bias names that you have previously used to access the resources. Because WINS provides the cross-reference from name to IP to address for you, when you install and configure TCP/IP as described later in this chapter, you'll see a place to specify the WINS server address. These addresses are stored with the configuration, and TCP/IP uses them to query for host names and addresses when necessary. WINS is similar to DNS in that it cross-references host names to addresses. However, as mentioned earlier, WINS references net bias names to IP addresses, but DNS reference TCP host names to IP addresses. Another major difference between WINS and DNS is that WINS builds its own reference tables dynamically, but you have to configure DNS manually. When a workstation running TCP/IP is booted and attached to the network, it uses the WINS address setting in the TCP/IP configuration to communicate with the WINS server. The workstation gives the WINS server various pieces of information about itself, such as the net bias host name, the actual username logged onto the workstation, and the workstation's IP address. WINS stores this information for use on the network and periodically refreshes it to maintain accuracy. Microsoft, however, has developed a new DNS record called DNS Server that allows the DNS server to work in perfect harmony with a WINS server. The Microsoft DNS Server software currently ships with Windows NT. Here's how it works. When a DNS query returns a WINS record, the DNS server then asks the sorry, then asks the WINS server for the host name. Thus, you need not build complex DNS tables to establish and configure name resolution on your server. Microsoft DNS relies entirely on WINS to tell it the addresses it needs to resolve. And because WINS builds its tables automatically, you don't have to edit the WINS tables when addresses change. WINS takes care of this for you. When you use both WINS and DNS on your network, or you can use one without the other, your choice is determined by whether your network is connected to the internet and whether your host addresses are dynamically assigned. When you are connected to the internet, you must use DNS to resolve host names and addresses because TCP/IP depends on DNS service for address resolution. So I'm going to leave it here today for this video. If you liked listening, please consider like, sharing and subscribing. And thank you again.